Hello students, welcome back. Today I am going to discuss with you circle. Yesterday I discussed the two theorems related to the circle. Today I am going to discuss another theorem based on circle. The first theorem says that equal chord of a circle are equidistant from the center. It means that if there is two chords are given to you, AB and CD are two equal chords. So we need to prove that OM equals to ON. They are equidistant from the center. So here given AB equals to CD, we need to prove that OM equals to ON. For that we need a construction. We join OA and OD. OA and OD are the radii of the same circle. Now we take these two triangles and prove these two are congruent. Now if these two triangles are congruent to each other, then by CPCT we conclude that the distance between O to M and O to N are equal. So we consider the triangle OMA and OND. We consider these two triangles to prove the congruency. Now we can say that first OA equals to OD. If you draw the diagram, you can see this OA equals to OD. The reason is they are the radii of the same circle. Yesterday I told you radii is the plural form of radius. AM equals to DN. AM equals to DN because AB equals to CD, and yesterday I explained you one theorem. If there is a chord and there is a perpendicular drawn from the center to the chord, it bisects the chord. So if AB equals to CD, then half of AB equals to half of CD, and half of AB means AM, half of CD means DN. So these two are equal, and one, it is a right angle. So we can say that these two triangles are congruent to each other. And if these two triangles are congruent to each other, therefore by CPCT we can say that OM equals to ON. Now let us take one sum based on circle. In a circle of radius 5 cm, AB and CD are two parallel chords of length 8 cm and 6 cm respectively. Calculate the distance between the chord if they are on the same side of the center and another side of the center or opposite side of the center. Now if you recall that length of two chords are given and there are two subpart of it. Two chords, once in the first part they lies on the same side of the center, in another case they lies opposite side of the center, and the radius is given to you. Now first I draw the diagram, I'll explain you the diagram and we proceed to solve the problem. Now see, corresponding to two subpart, I am drawing the two diagram. Now there is a circle. In the first case, it is given that the two chords lying on the same side of the circle. So AB and CD, these are the two chords whose length are given as 8 and 6 respectively. They lies on the same part. And in the other diagram, AB and CD are two chords which lies opposite side of the center. One on this side of the center and CD on the other side of the center. Now if you see the diagram, I name the figure as same, so it will ease your calculation. See, AB is a chord. A perpendicular is drawn on AB which meets AB at P, and we join the OB, which is the radius of the circle whose length is given as 5. Now look at this diagram. your naming should be same. So you doesn't need to do the calculation 2 times. So AB, chord, P is a point, OP perpendicular to AB, and we join OB. Same with the chord CD. Now we need to find out the distance between the chord. That means we need to find out PQ. Now in this case, PQ is equal to OQ minus OP. PQ equals to OQ minus OP. Now here PQ equals to OP plus OQ. So basically what we need to do, there is a two right angle triangle. One is OPB and another is OQD. Look at this, OPB and OQD. For both the triangles, we are going to apply Pythagoras theorem and find out the length of OP and OQ. So to find out the distance between PQ, one time we need to find out the difference and another time we need to add. Now see, AB is given as 8 centimeter. So PB equals to half of AB. If you are using the theorem 1, which says that if a chord, if a line perpendicular to the chord, then it bisects the chord. So PB equals to 4 centimeter in both the cases, and QD equals to 1 by 2 CD, that is 3 centimeter. Now I am going to apply the Pythagoras theorem on both the triangle, right angle triangle, and find out OP and OQ. So in triangle OPB, if you apply Pythagoras theorem, so you can say OP square equals to OB square minus PB square. If you calculate, you will get the value of OP as 3 centimeter. Similarly, if you apply Pythagoras theorem on triangle OQD, you will get OQ is equal to 4 centimeter. Now in the first case, it is a difference. So 4 minus 3 equals to 1 centimeter. So in the first case, the distance between the chord is 1 centimeter. In another diagram, it is the sum of those two distance. So PQ is equal to 4 plus 3 equals to 7 centimeter. Thank you student for watching this.